Hi, this is Mr. Erlin working with special right triangles, quiz number 9.3. There are two types of special right triangles. One is called 30, 60, 90 degree triangle because one of the interior angles is 30 degrees. The remaining one must be 60 so that this can be 90. It's a right triangle with specifically 30 and 60 as the other angles. The other one is called a 45, 45, 90, where it's a right triangle. This is 45 because I know that it adds up to 180. This one must also be 45. Whenever you're given one of these scenarios, a right triangle with either a 30, 60, or a 45 as one of the angles, you immediately go to this logic, this process called special right triangles. There's a very specific ratio, and we know that if two angles are the same in one triangle, another, that those two triangles are similar by angle-angle similarity. Therefore, the ratio of the sides is always the same. And what we learned is that if I have a side length here of whatever, I'm going to call it A. No, that's not a good choice because I already got the letter A in place. Let's call it S for side length. And if that's the side opposite 30, then the hypotenuse, the longest side, will be twice that, 2S. And the other side, the side opposite 60 degrees, has to be in between those two, which is called S root 3. And I know that the radical is somewhat difficult for people, but that's what it is. That's its precise value. So you're going to see three types of problems. One type of problem is, here's the 30 degrees, and you're given something here like, I don't know, 8. And you're supposed to find the measure of AC. Okay, so what you do is you'd look at your notes and you'd say, this is the relationship I'm supposed to have. In this case, 8 is in the place of S. Therefore, what goes here is something root 3. It's supposed to be what S times root 3 is. In this case, S is 8. So this answer would be 8 root 3. AC would equal 8 root 3. The second type is where you're given a, let's say you're given this is like 20, and you're supposed to find AC. Okay, well, 20 is now in the place of 2S. So if 2 times something is equal to 20, what does that something S equal? This is being multiplied by 2, so I'm going to divide by 2, and that means S is equal to 10. In other words, if this side is 20, this side must be 10. The side opposite 30 is the smallest, the side opposite 90 is the biggest, and the side opposite 60 will be in between those two. And what that turns out to be is S root 3. So if S is 10, this would be 10 root 3. And the last way that this might come about is you might be given the side here. Let's say that you're told that this is 5 root 3 and that this is the side opposite 60 degrees. Then you're asking yourself, okay, if this is 5 root 3 and it's supposed to be S root 3, just do a matching thing. The root 3 is already matched up. So what has to be here? Well, 5 is in the place of S. Therefore, in the place of S, this would be 5. In the place of 2S, it would be 2 times 5, which is 10. All right, again, this is the very basics of 36, 90, and 45, 45, 90 triangles. Now, 45, 45, 90 triangles are different. It's not these same ratios. It's a very similar process. This one would have been more like finding AB. AB would have been 10. Okay, so it's a very similar process. It's matching to a pattern. But in this case, if this side is S, and this side is S, then this side is S root 2. So in the event that you're given a triangle and you're told that it's a 45, 45, 90 triangle, and you're given that this side is 12, because this is 45 and this is 45, even if it's not shown, it has to be, because 90 plus 45 plus that angle B has to equal 180. 135 plus B equals 180. So B has to equal 45. In other words, if this angle is 45 and this is 90, this has to be 45. When you see two angles of the same, that means this is an isosceles triangle where this side and this side are the same length. So if this one's 12, this one has to be 12. And that's matching our picture. These are both S. And if S in both cases is 12, then what belongs on the hypotenuse is at 12 times a root 2. And that would be the length of the hypotenuse. What if, on the other hand, you were given that hypotenuse? You were told that this is a right angle, this is 45, and this is 17 root 2. You had to find this side down here. Well, if 17 root 2 is presented here, the root 2 is the same. And instead of S, it's got a 17. That means that in both of these places where it's supposed to be just S, you'd put a 17. So in this case, X would equal 17. Now, there are more challenging versions of this. For example, you can mathematically recognize that the way you go from S to S root 2 is by multiplying by root 2. So if you were ever given something like A, C, B, and you knew that this was 5 root 6, you could say that I know that if this is 5 root 6, this is the same, 5 root 6. And I know that this one up here would be that 5 root 6, that S, times root 2. And that is the answer. It's just not simplified. We'd need to then go through our process of simplifying radicals to say that means it's 5 root 6 times 2. We'd want to rationalize that or simplify that and say that that's, instead of 6, I'll call it 3 times 2 times this 2. I see that these 2's pair up, so they get to come out. And I get a 5 times 2 root 3. 5 times 2 is 10. So in this case, it would be 10 root 3 for this side length. But for today's quiz, you're just looking at these simple versions. Hope that helps.